Hi, BC Calculus students, it's Mrs. Charnley again. Today we're going to look at the second lesson in Unit 1 limits. We are looking at the definition of a limit and limit notation. So today we will understand what a limit is and be able to find one both numerically and by looking at a graph. To get started, I want you to graph the function x squared minus x over x and what is the value of f of 0. Now, this isn't a graph that you know by heart. That's not one of those that you should be able to graph on your own. So go ahead, pause the video, use your calculator, use Desmos, and see what that graph is. All right, so what I've done is I've gone into Desmos to graph this. So this is x squared minus x over x, which you can see over here on the left-hand side. And if you look at it, it's a straight line. It doesn't really feel like it'd be a straight line, but it is. And so the question is what's happening at f of 0. So if I take my graph and zoom in, I've got all kinds of stretches happening here. Well, it looks like f of 0 is -1, but if I use Desmos and try to click on this, can you see those numbers are not very dark? So I'm going to try to get over here, to 0. Negative value is getting really close. And my finger got in the way and I couldn't see. Right there, 0 undefined, and it shows me an open circle. And then if I keep going, it's defined. So the question is, why is that undefined? By the graph, it looks like it's -1, but it's really undefined. Well, if you go back to the original function, which I'm going to do here, if you go back to the original function and try to put a 0 in, this is f of 0 is equal to 0 squared minus 0 all over 0. Well, that becomes 0 over 0. And up until this point, we've told you that's undefined. When you divide by 0, we're going to have a different word for it here in calculus. We're going to call that indeterminate when I have 0 over 0. I don't know what it is. There's a little bit of work that we can do to figure it out. So we'll come back and revisit this warm up in a little bit. So what is a limit? The definition of a limit. Assume that f of x is defined for, oh, that's a lie. Assume that f of x is defined for all x values near c, but not necessarily at c itself. The limit of f of x as x approaches c is L, but x is not equal to c. So the limit as x approaches c of f of x equals L. That's really wordy. That's really mathy. But after a few examples, I think you'll see what's going on. So I like this next line. Basically, a limit is a y value of a function as the function approaches the x value, some value. So it's the y value of what it should be. It doesn't necessarily have to exist at that particular point, but it's what it should be. So if I come back to this one, there's a little bit of math that we can do there, but I want to go back to my Desmos graph. So here's my Desmos graph. So I know that the function doesn't exist at 0, but what should it be? I can't get right there. Bear with me here. Yeah, there it is. What should it be? What should be the y value of that undefined spot? Well, if you look at the line on this one, it's pretty easy. It should be -1. It should be -1. Now, I've also taken my graphing calculator and I put it in here. It's a little blurry. But I'm going to graph this. So when I graphed my line, if you've got your TI-83, there's my line. Even if it's backwards, you can still see it. But here's the interesting piece of this. If you go to your table, so I'm doing second function table. And mine's counting by 1 right now. You can see the x values. I've got negative x values, and then it gets to 0, and then it goes to positive x values. And then when you look at the y values over here, negative, error, that's where it's undefined, 0, 0, 0. But what I can do on my table is do table set. And I'm going to have it start at 0 and put in tiny values. I'm going to go with 100th. Those are my settings. And now when I look at the table, I can start to see a little bit closer what's going on. So those are my x values that are getting really, really close to 0, kind of like we did with the intervals yesterday. And then these are the y values. So you want to ask yourself, what should be where that error is? Well, if I follow the pattern, it should be a -1. It should be -1, which is what it looked like on the graph. So basically, that's what we're going to continue to practice today. So let me get my screen back. There we go. Are we there? I think we're there. You guys can see what's all over my iPad. There you go. So we talked about the definition. So finding limits from a graph. That's kind of what I alluded to on the warm-up. And hey, look, here it is. So as x approaches a value, we are looking at the graph to determine what y value the graph approaches. So the limit, so now this is our limit notation. The limit as x approaches 0 of x squared minus x over x. Well, remember that graph. And if it's still in your calculator, cool, mine is still in decimal. So here's my quick sketch. It looked like a line, but technically there was a hole. It's going to erase everything on me, I think. Yep. There was a hole at -1. Let's switch colors. So here's my arrow. There was a hole at -1 and it went up like this. So that was the graph that I had on Desmos or my graphing calculator. So when I look at this, the y value that it should be is -1. Now, we're going to have other ways to solve limit problems later, including algebra, using algebra, but we're just going to look at graphs today. So this is really important. The function does not have to exist at the value in order to have a limit. The function doesn't have to exist, or the function value may be different from the limit. So if I go back to this example up above, you could actually have a closed circle up here. It's still a function, but the limit would still be -1. You want everything that follows that pattern, that nice curve or that nice line. So here is what we're going to look at with a graph. I love limit problems with a graph. It can take a few minutes for it to click, but I tell you, once it clicks, and they're pretty easy. But if you're struggling, ask myself, ask Mrs. Oakes. We want you to be able to see it. Once you see it, it's okay, but it can be a little rough if you don't see it right away. So it's the limit as x approaches -2 of f of x. So over here is -2. Let's use a highlighter. So you are looking for the y value as x gets to -2. So we're coming up to -2 on both sides. What's that y value? It's 3. So even though it's an open circle, that's okay. When I have that limit piece, it doesn't have to be a closed circle. So this is 3. Number 2, f of 4 over here. So here's f of 4. Now, this doesn't have limit, just has f of 4, so that's function notation. So the x value is 4. I want to know the exact y value. Well, the exact y value is -2. All right, let's clean this up a little bit. Okay. There we go. F of -2. So over here, -2, f of -2. I have an open circle. So my open circle tells me that it's undefined. And what we can use in calculus is DNE. Does not exist. So the limit exists, but the function does not. Two very different things. For number 4, the limit as x approaches -1. Now, sometimes these are so obvious, you gotta ask yourself, is it really that easy? Yeah, sometimes they are. So x of -1, so here's -1. What's the corresponding y value? It's 2. Number 5, the limit as x approaches 4. Remember, this is a limit problem in number 5, not a function problem. So your limit problem, come over here to 4. The limit, you're going to follow that curve as opposed to the dot. So the limit is actually 0. The curve is up here, or the value of the function is down here. So the limit 0. It doesn't matter where that closed circle is. The limit is 0. Number 6, the limit as x approaches 0 of f of x. So here's 0. Here's my x value approaches 0. What's the limit? Down here, your y value is a -1. And then the limit as x approaches 1, this is number 7. So here's x approaches 1. There's your x value of 1. Before I tell you, try to come up with the answer on your own. Is it -1 or is it 2? It's going to be -1. That's where that line is or the curve is. I don't care where the closed circle is so much for a limit problem. I want to know where that curve is. So it's a -1. And finally, f of 1. That's where the closed circle matters. So that's where it's 2. All right, it can be a little bit tricky. If you're not seeing it right away, that's okay. Keep trying. It will click. I promise. It will click. Some students, they see it immediately. Some students, it takes a night of homework to really see it. So don't panic. And limits from a table. Before, when I showed you my calculator, you could kind of figure out, there we go. You could kind of figure out what that missing value was. So that's finding limits from a table. So you want to make some predictions, what's going on. So example 3, use the table of values to determine the given limits. Now, there's a lot going on this table, and there's crazy decimals, and it's different than anything you would have seen in Algebra 1, and that's okay. So the limit as x approaches -3. So here's -3. You want to look at these values. As x approaches -3, what does your y value approach? Remember, f of x is really y. And your answers to a limit problem are always y values. So as x approaches -3, what should be here? Now, I don't love this table. It's the example that we found, but it doesn't have a ton of value in it, so you can't see a huge pattern, but we'll go with what we have. If it's 0.5 on the left and 0.5 on the right, what do you suppose it is in the middle? It's probably 0.5. It would be great to have a few more values in there to know for sure, but we'll go with 0.5 on that one. For letter B, this is at -1. You know what? Let's change this typo. Let's make this a +1. +1, because that's what we have in the table. If I look at the table, these values are around +1. Okay. The limit as x approaches -1. Now, it's important to remember, it doesn't matter what happens exactly at 1. That piece doesn't matter. You want to know what's happening to the left and to the right. Are those approaching the same value? And the answer is yes. They're both approaching 12. Now, it did happen to match in this case, but remember, it doesn't have to. And finally, what else do we have? X approaches 2. So we're looking at this set of values. Now, on the left-hand side of 2, I've got a 26. On the right-hand side, I've got a -7. Are they starting to approach the same thing at all? Are they near each other? Do I see a pattern? I'm going to say no. So this one does not exist. Okay? So finding limits from a table as well. Eventually, we're going to do this with algebra, so you don't need the pictures or the tables, but they're good to know. They're good to know. So what I would like you to do, short and sweet today, is work on that second practice worksheet that I'll post for you. When I see you or when you see Mrs. Oakes, we can go over questions on practice 1, but today we're going to work on practice 2. So good luck. Reach out if you have any questions.